Yeah, hi. So my name is Alok Srivastav, and I am from Supermicro. And today we are going to talk about rethinking of system design for new wave of AI and GPUs and CPUs. So first of all, a little bit about Supermicro, who we are. So we are located here in San Jose, Silicon Valley, California. And we do have, global presence. We have branches in Netherlands, Taiwan, and also in Malaysia. So Supermicro is rated right now among the top 5 system solution companies in the world. And we are doing really, really well, especially in the space of AI infrastructure. And now we are in our third phase of progression. Initially, Supermicro started as a motherboard company, and then we moved to servers, and then right now, it is full solutions, full rack stack cable labeled solutions, especially for AI infrastructure. So that's where we are doing really well. So here is the agenda. Today we are going to talk about modern AI that is built on basically scaling parameters, and it calls for new architecture. So what I mean by that, we will cover a little bit about that. Large language models as the new computing platforms, and data center, it is considered as a new computer now for these modern AI workloads, and world's most advanced AI infrastructure building blocks, and Supermicro's full stack solution. So as you all know, right now we are at this strategic inflection point. And after the big success of predictive AI, now we are in this second phase of AI, that is generative AI. And now we are tending towards AGI. AGI is nothing but artificial general intelligence. So some say that it is 5 years away from now or 10 years away from now, depending upon how you define AGI. But the good thing is that right now, today, the focus is about the generative AI and large language models. And this particular change, it has started happening just in less than 2 years ago. I remember the exact date, that is 22nd of November, 2022, the day when OpenAI, they announced ChatGPT. And that pretty much shook the whole world with the capabilities and the capacities what AI or generative AI brings to the table. And from then onwards, things are changing at a tremendous pace. And in fact, that particular day is also referred as one of the watershed moment in the field of artificial intelligence, because that was the day it pretty much redefined how the computing was perceived so far. So far, so with this new paradigm shift, now human language is a new programming language, large language model is a new platform, and generative AI is the new app. So for end users, from end users' perspective, things are becoming easier and easier, and that's how it should be. Because in case if you want to democratize something, it should be easy to use, and it should be easily accessible to all. So that is the primary goal. And right now, what is happening with this new paradigm shift? As I said, the things are becoming easier and easier for end users. But under the hood, things were already very complex, and now they're becoming more and more complicated. And why this is happening? Because to define success for any AI, the most important, the most fundamental component is a well-trained model. And the model parameters are growing at a tremendous pace. In fact, I just mentioned about ChatGPT. That was based on GPT-3 model, which was with 175 billion parameters. And that was pretty much, just 2.5 years ago, that was a state-of-the-art model. And today it is pretty much mainstream model. And today's state-of-the-art model is with 1.8 trillion parameters. So you can imagine just in less than 2 years at what pace these model parameters are growing. And what it means basically, it means that lots and lots of compute capabilities needed for these models not to be trained, but also to keep these models updated. And that's the area where Supermicro really shines, because Supermicro is among the first few who paid really, really attention to this particular, the change that was happening. And we are the first one who are really, really doing well in these 3 particular spaces. Broadly, you can classify all these modern data centers into 2 main categories. The first one is called AI Factory, and then the second is AI Cloud. AI Factory is nothing but the whole data center, it is acting as a computer, because the workload is so huge that the whole data center acts as a computing block for these modern AI workloads. And in this particular scenario, the most important thing is that the network fabric that is used in AI factories, that is InfiniBand, compared to, in contrast to the AI cloud. In AI cloud, it is about just like regular cloud. You have multiple users, multiple tenants, multiple type of workloads. So in this particular space, it is Ethernet. So this is the key differentiator in terms of how all these nodes they are connected, and the vertical integration, what it calls for the AI factories. And this is the area where Supermicro is doing really, really well, and we have done world's largest deployments in these two. And in fact, there is third one that I will talk a little bit later in my slides. So what goes inside these data centers? So on the screen, you can see the 8U system. This is our flagship product. And this is sort of our flagship product, second generation of our flagship product. The first one was powered by 8 amperes, and this is powered by 8 hoppers in XXM form factor. And this particular system very well received in the market. And as I mentioned, we have done the largest deployments in the world based on this particular platform. And this platform is powered by 8 hoppers in XXM form factor. And it is capable of generating up to 32 petaflops of compute power. Because all these modern AI workloads, they call for lots and lots of compute capability. And with the previous generation, it was 5 petaflops, now 32 petaflops. And this particular unit is air-cooled. And we are pretty much aware that most of the data centers are still, they don't support liquid cooling. So that's why this unit is of utmost importance in this particular space. And then the second one, just after that you see is in 4U form factor. This is also same thing, powered by 8 hoppers in XXM form factor, capable of generating the same compute capability. But here you get the most compute density at a rack level. So what you get out of this 8 systems, 8U GPU system, the air-cooled version, you can either simply double the compute density, or you can even go beyond that. Because in our rack, it can support up to not only up to 8, but it can go up to 10 systems. This particular system, the liquid-cooled system. And you get the best possible TCO available in the market right now based on this particular liquid-cooled system. As soon as Supermicro introduced this liquid-cooled system, and we were the first one, it was an instant hit. And we deployed one of the largest cluster that is based on this particular system, powered by the 8 hoppers in XXM form factor, 4U liquid-cooled version. And that was based on 50,000 GPUs cluster. 50,000 GPU cluster deployed in record time. That was just in 122 days. The day we received PO and the day we finished the job. That was 50,000 GPU deployment in 122 days. And that was just after we introduced this particular solution. So based on this particular success, what we have right now, we are also coming up with our next generation platforms. The one that you see on the screen, this is 10U system, powered by 8 Blackwells. So the previous generation hoppers, this is Blackwell. So Blackwell 10U system powered by 8 Blackwells in XXM form factor, and then the 4U liquid-cooled version also powered by 8 Blackwells. So here also, in terms of compute capability, lots and lots of compute density, because that's what these modern AI workloads calls for. So lots and lots of consolidation in terms of compute capability you get on these systems. So the key here is that all in this architecture, all these GPUs, they act as a monolithic compute block. And that is what is needed for these modern AI workloads. And these two systems, the 10U system, what I was referring to, and the 4U system, they do that job. But now, since we were talking about 175 billion parameters to 1.8 trillion parameters, those type of workloads, so Nvidia came up with this one, the newer architecture. You all might have seen number of these deployed here on display in different booths as well. And the Supermicro version is on our booth that you can see, that is GB200NVL72. So here 72 represents the number of GPUs, 72 Blackwell GPUs, and they act as a monolithic compute block. That is the key here. So it acts as a monolithic compute block, and in terms of compute capability, it brings lots and lots of compute power. We will discuss that also later. And why we call this as a node, because this is just as a node, 72 GPUs packed in a monolithic compute block. That's how it acts. So let us go to the next one. This is our X14. X14 is Supermicro nomenclature. This is based on the latest Intel CPU, that is Xeon 6, Xeon scalable, Xeon processor, that is 6th generation. And this is also powered by 8 Blackwells, as I mentioned earlier. And one very important thing here is that on this particular system, it supports DDR5 memory and 24 DIMM slots, so it can go up to 6 terabytes of local memory. And also this supports MRDIMMs. So with MRDIMMs, you get more memory bandwidth and lower latency. So in a nutshell, this particular compute block, it offers all the latest and greatest, including starting from the CPUs to the memory to the GPUs, what I have already mentioned, the Blackwells. So all that packed in this particular in 10U form factor, and it is capable of generating up to 72 petaflops of compute power. So if we compare with the previous generation, that was 32 petaflops, and now in 10U form factor, you are packing up to 72 petaflops of compute power just in 10U form factor. So this is going to be our next generation platform for Blackwell, and we do have the liquid cooling version also. Here, this is again in a 4U form factor. The previous one, the 4U form factor, what we were talking about earlier, that was 32 petaflops, and here it is 72 petaflops. So same form factor, but 32 to 72 petaflops, so lots and lots of compute power packed at a node level. So in terms of compute density, it is same, what the 10U system offers and this 4U liquid cooled version offers. But in terms of density at rack level, you can not only double, in fact, you can go beyond that, because in a rack, we can support not only up to 8, but it can go up to 10 of these systems at a rack level. So what it means basically, that at a rack level, you can generate up to 720 petaflops of compute power by using this particular system. So lots and lots of compute density at rack level. So you can take it either ways, either take double the compute density, or you can just reduce the rack footprint in your data center. The most important one, since this is creating lots and lots of buzz, that is GB200NVL72. So this is Supermicro version, the one that you see on the screen now. And some of you who are not familiar with this one, so this is an entire rack solution. So here 72 represents the number of GPUs, as I mentioned earlier. And all these GPUs, they act as a monolithic compute block in terms of compute capability. So right from the beginning, at the top, you can see the management switches. And after that, these are 4 power shells. Each is 33 kilowatts, 3,300 kilowatts. And after that, there are 10 compute trays. So each compute tray, you might be familiar that each compute tray has 4 Blackwells, 4 GPUs per tray. And there are total 18 trays. So 10 trays, and then 9 in the middle that you see, these are NVLink switches. And then again, 8 compute trays. So total, there are 18 trays, and each tray has 4 GPUs. So that's how this number 72 comes in. Below that also, there is, again, the 4 more power shells. And at the bottom, the bottommost that you see on the screen, this is CDU. This can go up to 250 kilowatts. 250 kilowatts, and the total power required for this particular rack is 120 kilowatts. So you get N+N redundancy. And this particular CDU, as I mentioned, this can support up to 250 kilowatts. The good part is that on this particular solution, Supermicro, we have from the cold plates to the CDU to even the cooling tower. Everything is done by Supermicro. Even the cooling tower, that also we do. We have done some deployments from cooling tower to the cold plate. So everything is regulated by Supermicro. So you can just, you have one throat to choke, only one vendor. So who will take care of all this stuff? So the most important thing is what is unique with Supermicro. So Supermicro is the only company right now who has done liquid cooling deployment with this high-end systems based on, earlier I was sharing about the 4U liquid cool systems and all this stuff. So we are the ones who have done very large deployments based on liquid cooling. And when we introduce this particular system, we come with experience. So this is one very big USP that we have, that right now for all this tight vertical integrations, we have done, thousands and thousands of nodes deployment. Doesn't matter it is air cooled or liquid cooled, especially in liquid cool. The recent one, the biggest one in the world, that was done by Supermicro. So that experience comes with this particular platform. Little bit more in detail about this architecture. So as you can see inside, inside the tray, what is there. So each tray, as I mentioned, it has 4 Blackwell GPUs and 2 Grace CPUs. And if you notice, there is CX7s. So there are 4 CX7. These are the networking ports. It supports up to 400 gigabit NICs. And pretty soon it is going to be 800 also, CX8. But right now it is CX7. So the key here is that the GPU to NIC ratio is same, 1:1. 4 NICs, 4 GPUs per tray. And that is same on the HGX platforms. So similar to HGX platform, that's why that is a node where 8 GPUs act as a monolithic compute block. Here it is 72 GPUs that act as a monolithic compute block. GPU to NIC ratio is same over there and here also. And I already talked about this particular architecture and what Supermicro brings to the table. The next very important thing is that at Supermicro we always have the largest GPU server portfolio. In fact, the AI infrastructure portfolio in the industry. We have the largest one. And broadly, it can be classified into 2 main categories, the X14s and the H14s. X14, they represent Intel-based, Intel CPUs, Intel platforms, and H14 is AMD platforms. So Intel, as I mentioned, this is 6th generation Intel Xeon processor, and the H14, this is EPYC, AMD's EPYC processor, 9005 series, so that's what H14 stands for. This is Supermicro's nomenclature. And in terms of DIMM slots, 24 DIMM slots on both of them. And as I mentioned earlier, there are a number of other new features what this particular broad portfolio that brings to the table. So this portfolio, when we talk about this, that okay, we have the largest GPU server portfolio or AI infrastructure portfolio in the industry, this is not to confuse you. But if you know your workload exactly, what you're looking for, Supermicro can help you. Supermicro can configure the system exactly according to your needs, what exactly you're looking for. So little bit on this one, what we have in terms of, for these large cloud deployments. So this is the cloud data centers. Specific to those, the 1U and the 2U, that particular falls in this category, that is cloud DC. And for here, we do have both. It supports both Intel and AMD platforms. And this particular architecture, this is very, very flexible architecture. It can be configured in a number of ways. As I mentioned earlier, if you know exactly what you're looking for, it is modular in design. So you can just configure this system exactly according to your needs. And this is 1U and 2U form factor. And it also supports this OCP 3.0, the AIM, that is advanced input-output modules that supports OCP 3.0, compliant to OCP 3.0. And then the next very important thing is that it also supports DCSCMS. So all that stuff, on these compute platforms, if you're interested, you can see all these on our booth. This is on display. And the GB200NVL72, the 4U liquid cool versions, what I was referring to earlier, they are on display on our booth. So please visit, come to our booth, and you can take a look to the physical systems, these one. So far, we were talking only about the compute side. On the networking side also, Supermicro, we have this SONiC-based Ethernet switch family, and number of options are available, 100 gigs to 200, 400, and even up to 800 gigabit NICs, they are available Ethernet. And there are multiple options, more and more details. If you want to get more details on this one, it is available on our website and also on our booth. You can come and talk to our team members about these type of deployments. So the third compute fabric, what I was referring to earlier, that Supermicro has done the largest deployment, that is based on this, the Spectrum X. So that is from Nvidia, the DPUs, you call it the Bluefield cards and the DPUs. So that was used for the networking. And this 5600 series, this Spectrum X switch, so this was launched by Supermicro at Computex very recently. And in terms of the difference, what it brings to the table, earlier we were talking about the Ethernet and the InfiniBand. These are the two major network fabrics used in these data centers. But if you go by this particular architecture and this network these NICs, what you can get up to 1.6x better performance in terms of, if you compare it with the Ethernet. So that's what it brings to the table. And I was, earlier I was mentioning about the 50,000 GPUs deployment that Supermicro has done successfully recently, and that too in record time. So for that particular deployment, this was the network fabric that we used, that we deployed. In a nutshell, Supermicro is a total infrastructure solution company. And in fact, just in a one line, how we sum up that, okay, Supermicro is technology provider for AI infrastructure from edge to cloud. And you have multiple options to pick and choose. In fact, the highest number of AI infrastructure building blocks available in the industry to pick and choose from. And in terms of the networking, we work very closely with Nvidia. So this particular network topologies, we have used multiple of them for these thousands. And in fact, the world's largest deployments we have done successfully. So our team of experts, they can help you in any of those type of deployment. It doesn't matter to what its scale it goes to. And at last, Supermicro, we have this plug-and-play solution. So from end to end, the whole rack stack cable-labeled solution that Supermicro provides, and that's the area where Supermicro is excelling now. So this is all from my side. Any questions? If no, then thank you. Thanks for your time, and enjoy the lunch. This is from Supermicro. That was lunch time.